Continuing to work with reduction formulas, I want you to construct a reduction formula for this down here. And I've given you a hint, like in the last video, this should be your first step. It would help you out. So, given all of that, why don't you pause the video and try to construct a reduction formula? All right, assuming that you've given it a go. Again, similar to the last video, I gave you this hint here. That's going to be our first step, so writing that out, we are going to have, let's get that in blue first. All right, writing this out, we're going to have under our notation, capital F sub n of x, and that is equal to this indefinite integral of sine of x to the n minus 2 power, times sine of x squared, dx. That's our first step, where this is equivalent to what we have in this integral up here. But the whole reason why we did this, and we saw this in the last video, is that this right here allows us to use a trigonometric identity, specifically on this guy here, sine of x squared. So we can come up here, and we can remember our trigonometric identity. This is going to be equal to 1 minus cosine of x squared. Okay, and now we can apply this. So let's see what we get now. So we have sine of x to the n minus 2 power. All right, and then times, we're filling this in our trigonometric identity. So 1 minus cosine of x squared. And we're still integrating with respect to x. So this is what we have now. And again, this is following pretty similar to the last video, if you watch that one. Now we're going to distribute this guy here, and we will eventually get two separate integrals, but we'll do this step first. So we're going to have sine of x to the n minus 2 power, and then minus sine of x to the n minus 2 power, n minus 2 power, and then times cosine of x squared. And then all of this we're integrating with respect to x. Now that we have this, we're going to split this into two integrals, two indefinite integrals. So let's do that. Let's get this into two integrals. So our first integral is going to be sine of x to the n minus 2 power. And then we're integrating this with respect to x. And then we have minus this indefinite integral of sine of x to the n minus 2 power times cosine of x squared dx. There's our two separate indefinite integrals. And again, where are we headed here? Well, we were trying to, again, the whole thing with this reduction formula, we're trying to express this integral in terms of a simpler integral. And we've already made some progress on that. We're trying to make some progress on that. And in terms of our notation here, it looks like we found something right here. What is this guy? This is capital F sub n of n minus 2 of x right there. So we got a piece here, but we still have this integral over here. And again, we want to try to get this in terms of some of our notation as well. Capital F sub something simpler. So n minus something of x. And again, what you've seen in the last couple videos, we need to end up using integration by parts at some time. So we're going to start looking at this integral exclusively here and see how we can start thinking about applying integration by parts on it. Let's grab this integral. So sine of x to the n minus 2 power, times cosine of x squared dx. And again, we want to try to apply integration by parts on this guy. And you might say, why? And you might say, well, can I just apply my another trigonometric identity here? You know, I could go 1 minus sine squared, and I'd have everything in terms of sine. You would just be undoing what we just did up here. It's a good thought, but you'd be undoing what we did up here, and you'd just end up returning back to our original problem statement. So we need to move forward and make some progress, and in order to do so, we need to apply integration by parts. But the question now becomes, okay, what's u and v prime? What's u and v prime? That's kind of hard to see in this. But if we were to rewrite this, I think it becomes more evident. So if we were to rewrite this, we could rewrite this as sine of x to the n minus 2 power, and then we could split this cosine squared up into cosine of x times cosine of x, and then still integrating with respect to x. And now I would argue that we can come up with candidates for u and v prime. mainly this guy right here, we're going to say is u. And then this other guy right here is going to be v prime. And why is that? Well, we know what the derivative of cosine of x is. Mainly, this is v prime because we can take its antiderivative. Because we know that sine of x, its derivative is cosine of x. So we can end up taking this antiderivative. Now, let's apply integration by parts. Maybe pause the video and give this a try on your own. We said that this guy right here, u is cosine of x. Okay, and then its derivative is negative sine of x. And then we said v prime. We said that v prime is going to be sine of x to the n minus 2 power times cosine of x. And we can take its antiderivative. It's just going to be undoing some of the chain rule here. So we have 1 over n minus 1 times sine of x to the n minus 1 power. And you could differentiate this to check it. You'd have n minus 1, you'd use some power rule here, that would go to 1, decrement the exponent, n minus 2, derivative of sine of x is cosine of x, and boom, we're right back to what we had for v prime. So hopefully that's feeling good to you. Now let's continue to write out integration by parts. And again, this is equal to this integral up here. So we have u times v. I'm just going to leave everything in pink now. That'll save us some time. So we have u times v. So that's cosine of x times 1 over n minus 1 times sine of x to the n minus 1 power. And then we have minus this indefinite integral of v du. And that is going to be 1 over n minus 1 times sine of x to the n minus 1 power. Okay, and then we have times negative sine of x. I'm just going to take that negative and throw it on this 1 here. So we have sine of x right here, dx. And there is integration by parts. And again, what are we after here in applying integration by parts? We're going to try to get this integral in terms of our notation here. We want capital F sub something simpler. So let's see what we can do to mess around with that integral to make that happen. And it looks like we can take this negative 1 over n minus 1 out of our integral. That's just a constant. So that helps us out. And then we can add these powers together. And it looks like we're just going to have, so that's going to be n minus 1 and then plus 1. So we're just going to be left with n as our power on sine of x. So we get the following here. Here we go. Cosine of x over 1 minus n minus 1 times sine of x to the n minus 1 power. Okay, and then we took this negative 1 over n minus 1 out of our integral. This came out of our integral. And then these negatives are going to cancel, and we're going to get a positive. So you have plus 1 over n minus 1 times this indefinite integral. And we said we had sine of x to the nth power up here, dx. That's what we have. And what's cool is, what is this guy? What is this guy right here in our notation? If we were to scroll back up a little bit, just remind ourselves, we've been calculating for a while, that is just capital F sub n of x. That is capital F sub n of x right here. Capital F sub n of x. And now let's write out our full, what we got out of this integration by parts. And then we can't remember the piece that we calculated earlier. So we'll take what we have here and bring it back up in a little bit. So let's write this all out. This is going to be equal to cosine of x times 1 over n minus 1 times sine of x to the n minus 1 power. Okay, and then we have plus 1 over n minus 1 times capital F sub n of x. And then we're going to take this guy, I'm going to copy paste it, and we're going to bring it back up to what we calculated earlier. So copy that, and then come back up here. And remember, we're subtracting what we just found. So that's going to go right here. We're going to be subtracting all of this right here. Let's get my pen back. So minus all of this. And what is this equal to? This is equal to capital F sub n of x. And the question is, are we done? And the answer is no. We want capital F sub n of x is equal to something else. But you can see we have capital F sub n of x on this right-hand side. So we need to solve exclusively for capital F sub n of x to be finished. So let's wrap up this problem and solve for that. Let's grab some extra space. Maybe we'll use this up here. Want that in white. Okay, there we go. Right here. Something like this. Some stairs. All right, let's bring up what we had. So this is capital F sub n of x, and that is equal to, we have capital F sub n minus 2 of x. All right, and that is, we are subtracting all of this. Let's see if I can still get that copy paste to work. There we go. All right, just barely gonna fit. All right, and we're subtracting this. So let's distribute this negative. It's going to be negative on this first term, and then we distribute it to the second term, and this is also going to be negative. So this is going to be a minus sign right here. Minus sign. Just rewriting what we had down here. And again, now we want to solve for capital F sub n of x. So we need to add this term over, and we can do some factoring over. Maybe we can skip a step, just one. So we'll add this term over, and we're going to be left with what here? This we can factor out. I'll leave that in blue. So this is capital F sub n of x. And then we factor that out, and we're going to be left with 1. We're going to be left with 1 plus 1 over n minus 1 here. We're going to be left with that. We added this term over, and then we factored out capital F sub n of x. And this is what we're left with on this left-hand side. So we got rid of that. And now I'm going to save us some time here. This right here is what's left on this right-hand side. So let's continue to simplify this left-hand side, and we're so close. We're so close. So let's get a common denominator of n minus 1. So we'll have n minus 1 up top now, plus a 1, so we're just left with n. We have this here, capital F sub n of x, and then times, we're going to have n over n minus 1. That's still on this left-hand side, and we still have what's underlined on this right-hand side. And then finally, here we go. Here we go. This is it. Capital F sub n of x is going to be equal to, we're going to multiply both sides by n minus 1 over n. So we're left with this guy right here. We're left with n minus 1 over n times what we underlined over here. Let's see if I can fit it. So we're going to have capital F sub n minus 2 of x, okay? And then minus, we're going to have minus cosine of x, and then maybe I'll throw this n minus 1 in its denominator, so over n minus 1, times sine of x to the n minus 1 power. N minus 1 power, and we got it to fit. There we go. This right here is our reduction formula. So it took us quite a bit of time and calculation to find this reduction formula, but now, again, this is the hardest part. Once we have it, then we can use it, and this greatly simplifies our calculation. So hopefully you got a little more comfortability with constructing reduction formulas.